we have Kevin Kennedy, who is an inventor and founder of Pacific Petroleum Recovery Alaska, based in Anchorage. Mr. Kennedy is a leading marine logistics expert in the oil and gas, mining, and fishing industries in the state of Alaska. Kevin has spent over 35 years operating Bering Sea crab boats, ocean-going tugboats, and barges. As a result of a lifetime on Alaskan seas, Kevin has served on or taken a leadership position at nearly every major oil spill response in Alaska, from the Exxon Valdez to the Selendang IU, and outside of Alaska, the New Carissa to the Deepwater Horizon. And today, Kevin's going to be discussing high efficiency boom and skimmer systems for cleanup of hydrocarbons in diverse environments. That title change is a little different from the agenda. And Kevin was supposed to join us 2 years ago at the last event, but wasn't able to, so we're happy to have him here today. And Kevin, if you could hop on and share your screen, we can get started with your presentation. I'll hand it off to you. Thanks.
Okay, thank you. Hello, my name's Kevin Kennedy, and you can see my presentation that title of it. Go ahead, next slide. One of the things that I worked on over the years was, and have come across, is trying to connect an effective daily recovery capacity versus what's actually listed on systems. And they don't normally match up. You'll see skimmer utilizations and what they're supposed to be capable of, and actually what they do collect and skim are usually vastly different from their stated or rated capacities. So that's kind of where I'm starting with this. Next slide, please. PPR Alaska was formed right during the Deepwater Horizon. What had happened was I had built a skimming system. It actually goes back to the Exxon Valdez quickly. I got out of crab fishing in the Bering Sea and went into Prince William Sound to become a shrimper because I wanted calmer waters. And the opening day of shrimping season was the day the Exxon Valdez ran aground. And at that point, I started using my shrimp vessel and the net that I had and the shrimp pump to collect oil during the Valdez oil spill. And so it just kind of grew from there. And I watched how all the skimmers were used and the boom was used during the Exxon Valdez. Fast forward 25 years later, 20 years later, and I was out in the Bering Sea putting in tsunami warning buoys when the Selendang IU, which was a container or a grain ship, ran aground on the north side of the Aleutian chain right outside of Dutch Harbor and broke in two. And I was the first vessel on scene, and I got to be firsthand there with Alaska Shadow, and they started pulling out these same skimmers that didn't work during the Exxon Valdez oil spill. So at that point, that's when I formed the company and started building, or trying to accomplish, building a better skimmer and better boom. Next slide, please. So there's several things that you have to try to understand when you're trying to solve the problems and the hurdles that come with traditional boom. As you can see from the picture to the left there, the vessels are towing through. This was during the Deepwater Horizon. They're pulling right through the oil, and because of the current and the speed and the waves, the oil just comes right out the backside. So you've got a lot of problems with boom. They don't work past 0.8 knots most of the time. They're ineffective in waves. They're also extremely heavy. Where I live in Alaska, you can't use them with ice. And then when you attach a skimmer with these, nobody at the time truly made an advancing skimmer system. And they were also extremely heavy. Next slide. These are just a couple more variant pictures. You got a shrimp boat off to the left there. You can see the oil coming right out of the boom behind them. Also, you got the Coast Guard cutter down below, buoy tender actually, and you can see where they're pulling their boom and it's doing the same thing. You can see the oil leaking out next to the ship. Next slide. These are just more pictures of the same. It's a definition of insanity. We do the same thing over and over again, expecting a different result. Next slide, please. So you have to start taking a look. These are graphics that were done by Nuka Research, and I've worked with them quite a bit. The top picture shows what happens when you have a flow of water hitting a containment boom and the skirt and the ending result of it. And then the bottom picture shows when you start to add oil to that, where it kind of leaks off. So I took a step back and tried to figure out what was causing this. Next slide, please. So when you have solving problems with your booms, and I call this Boom Issues 101 because it's amazing how many people in the oil spill response business don't understand hydrodynamics. But making boom work at a speed greater than most currents that are encountered in the oceans and rivers seems like a really easy task, or seems simplistic. But it's a little bit trickier than that. Next slide, please. This is a video, and off to the left, if you can. So this is a video that was put together with myself, Alaska Shadow, and the Alaska Prevention Marine Network. And what we're trying to, after seeing videos and working at OMSET, we started to see what was happening. And so when you have all this incoming, it forms a pressure wave. And what that pressure wave does is it has to relieve itself. And with a typical boom, they're solid. And so that pressure wave increases. And as it does, it starts to pull, for lack of a better term, a vacuum to pull everything out of the inside of that boom down and underneath it. So the trailing edge of this starts to fail, and it starts to fail at 0.8 knots, but it catastrophically fails at 1.1. In other words, it just flat out fails. It doesn't hold any oil at all. So I went after this trying to design a net system and smaller floats that were more flexible. And the end result was that I'm passing water through the net, and I'm not building a pressure wave to push the oil out or underneath it. Therefore, I can collect oil at a much faster speed than regular boom can. So now you could start to see that you could advance nets and not have the problems that the pictures that I showed earlier, the hurdles that you have. I have actually towed this net now at OMSET in excess of 5 knots, and I've done it in the ocean at 10. So this is just the video showing a graphic of how this takes place and what happens. Next one, please. The next one, the next hurdle that you have to overcome is waves. Waves, for lack or an easier way to describe it, is every wave that hits a boom is also a speed differential. So not only do you have the actual roughness of the water going up and down, but each time the boom has to go up or down, it's increasing or decreasing the speed in which water and oil is hitting it. Next slide, please. This is also a video of that. This is a demonstration of what it looks like with waves. When you have hard boom like this, it can't flex, and so it just exasperates the problem even more. It makes it worse and worse. So in this video, you can see how everything is topsy-turvy and twisting, and when that happens, the boom has to fail to relieve all of the pressure that's stuck inside of it. Again, when you go back with a net, what happens with the net is it's extremely flexible, it's extremely strong, but it allows everything to twist and manipulate independently, inch by inch, instead of over 5 and 6 foot lengths, which is what typical boom is, which is really stiff and it doesn't bend. So those are kind of the differences between them. So now that I've understood this, the next step was to actually build it. Next slide, please. Oh, this is the actual video. Go ahead. This is a video. This was done by Exxon and Desme in '98. Okay, this is back to that quick video. It shows at what point the oil starts to just exit. And as you can see at 0.8 knots, it's starting to come out from the front. And then at one knot, and then at 1.1, it fails. This is at ohmset. This is 2 knots. This is a net. You can see you can see right here that it's a net with chain. And this was a test for the Coast Guard because they just couldn't believe that I could use a net to collect oil. So I'm not pumping any oil. They're just spraying 100 gallons a minute in front of me as we're advancing at 2 knots. And as I collect this oil, you'll see it start here at the very end where it starts to come out. And that's because eventually this whole pocket back here is completely full of several hundred gallons of oil. But as you move forward with a net, it creates a foil on the sides, and it has a high pressure on one side and a low pressure on the other, and it just forces the oil to the center and to an apex. So once you've gone through all of that, in order to keep the system from being overwhelmed, you have to somehow get the oil that you've collected out of it if you're in an advancing mode. So this is what we call the Sea Otter. I took a system and attached it to my net. And the way the Sea Otter works is I'm skimming off the top oil because I've now collected all that oil in the top 12 inches of my vinyl area there in the net. And the net flexes and moves just like the skimmer will with it and follows it. And as that oil comes down the vinyl area, it enters into a suction, and I pull it underwater with a vacuum, and that enters into a chamber. And once in that chamber's at anywhere between 20 inches of mercury and 27 inches of mercury. And that's a measurement of vacuum. And it pulls that up and above the water line. Once you've pulled that oil up and into the above the water line, any residual water that's in it in a vacuum boils, and so it evaporates. And so all I get is just pure oil coming out of the top. Once that has run its course, this float ball that's in there comes up and it tells the vacuum pump by a huge increase in vacuum that there's nothing left. And I inject air back into it by atmosphere, and the water just falls out the bottom. Any residual oil never goes below the water line because it doesn't have the energy to do that. And then it just alternates back and forth between tanks. This is actually on Taylor Energy in the Gulf of Mexico. I wanted to go out and actually test all of the stuff instead of being at ohmset in the real world. This is a 1 micron sheen. It's a long story, but Taylor said they were leaking 4 gallons of oil a day. And we were out here collecting 40 gallons an hour off of the 1 micron sheen. And this was just my first test on my big system. And this system was capable of doing 300 gallons, pumping 300 gallons a minute. So I then went on from there, got a phone call from up in Ashland, Wisconsin, and they were excavating creosote off the bottom of Lake Superior. And so they said that they had tried mini skimmers and it was so thick and heavy that it was starting to plug up all their skimmers. So this was the picture on the left is just us taking the big sea otter out there and testing it. To the right here is to show you the scalability difference. So the one to the left weighs about 450 pounds and takes 20 horsepower vacuum pump. The one on the right weighs a little over 100 pounds, the in-water component, and 2 people can pick it up and set it right in the water. These are just different jobs that I've done. The one on the left is in the Gulf of Mexico. The one in the middle screen lower is Ashland, Wisconsin. The one on the upper right there and the tote to the right is Long Beach, California, right at the port where they were cleaning up the site from an old Navy fuel farm that was there. And then down below to the lower right, down here, this was a fuel pumping station from a pipeline that Canada used to send jet fuel from British Columbia all the way up to Fairbanks, Alaska. And that pipeline was abandoned, but they never emptied all of the line and they just let it break apart and rot out. And out in the middle of a swamp and 300 miles away from anything, they needed a skimmer out in the swamp. So that was just this last summer. I'm back to this frame because this is something that the North Slope Borough, working with myself and Alaska Shadow and the Marine Prevention and Response Network, we are actually working on putting these skimmers now in 8 of the villages on the North Slope Borough. And we're negotiating out that contract now because they wanted, after the COVID stuff, they needed to be able to have oil spill response in an emergency without being able to fly people in. And they needed something that they could actually learn how to use and with no equipment and no docks, get it in and out of the water on their own. So we're in the process of putting all this together and training each village so that everyone in the village can operate this. This is just quickly what it is. It's a 45 gallon a minute skimmer and it's been ASTM tested at greater than, it's actually 99.75% oil recovery efficiency. We use bladders that are quick unfold and filled up for our recovery. It uses just a 2,000 watt generator, one of those little Honda generators. It comes with a 25-foot long by 25-foot wide net that can be run with their whaling skiffs. And the total system for the pump, the net, everything combined is 700 pounds. And that's it.
Great. Thanks, Kevin.